Hi, everybody. This is now chapter 19. We're going to move into electrochemistry here. So, electrochemistry is based on something you learned in the previous course called reduction oxidation or oxidation reduction reactions, often referred to as redox reactions. So electrochemistry is a subset of redox reactions, a very important one from technological perspective, because batteries and fuel cells are based on electrochemistry, as is anodizing surfaces, corrosion, which we often refer to as rusting. Those are examples of electrochemistry. And the idea is that chemical reactions can cause electrons to move from one reactant to another. And if we're clever about it, we can use that movement of electrons to generate electrical energy. So it's a very useful subset or subject of chemistry, very big these days as many researchers around the world are attempting to make better battery technology. So what we do in this chapter is we begin by looking at redox reactions in balancing for the most part. Really what we do in the first couple of topics, you'll see this in the Alex homework, is we do a lot of balancing of redox reactions. So the notes here have some discussion of oxidation states, the rules for assigning oxidation numbers, right? And then some methodology of balancing redox reactions, either in acidic or basic solutions. So many redox reactions really require either that the solution be acidic or the solution be basic, one or the other. And so that turns out that leads to some challenges in terms of how we balance the chemical equations because we have to take the acidity into account. So what you do in the first section is really you just go through learning how to balance chemical equations using the half reaction method for acidic and for basic solutions. So the lecture notes have a couple of examples, one in the acidic solution, the other one in a basic solution. Okay. Once we get past that, the basics of redox chemistry, we then look at the galvanic cell, which is the basis for chemical batteries. The galvanic cell is the idea that we have two electrodes, a cathode where reduction is occurring, an anode where oxidation is occurring. Electrons are flowing from the anode to the cathode. And in that process, we can use that to generate electrical energy. So a couple of examples, very common examples, probably the most typical introductory example is the reaction of zinc and copper 2. It's visual, it's something you can look at, but it also gives you a very reproducible voltage of about 1.1. Zinc and copper. So you'll go through the process of learning what a galvanic cell is, how it's designed, and then how to do some calculations with it. If you have time, you can actually make your own battery using a potato or a lemon, that sort of thing. Then we go a little bit more into the details of calculations. So we look at what are called standard reduction potentials, which is the idea that if we take one reactant and another and combine them, we can measure a potential, an electrical potential, but we want to actually make a table of individual potentials. So we do that using the standard hydrogen electrode. So that's discussed there in that section, the standard hydrogen electrode with some of the notation. This is called line notation, cell notation, I should say. And then we get into some of the standard values, the standard reduction potentials, which you can use to do calculations. There are several examples throughout the lecture notes, so that can help you to get into that. And then we get into going back and talking about how does electrochemistry, because it does involve electrical energy, how does that connect in with thermodynamics? So we'll see that there are some very simple calculations we can do to connect electrical reduction potentials, cell potentials to things like free energy chains, Gibbs free energy chains. So you'll see that in that section as well with, again, multiple examples to give you some practice at that. Then we'll look at looking at solutions that are not under standard conditions. It's often confusing to introductory students, this idea of the standard conditions. Comes up a lot in thermodynamics, and it also comes up in electrochemistry. The standard conditions typically refer to a situation where any ions that are involved in the reaction have a concentration of 1 molar, and any gases that are either reactants or products in the reaction have a pressure of 1 atmosphere. And that's rarely the case in the world, right? So that means that we need to be able to calculate these thermodynamic quantities when conditions are not under standard conditions. They're not at 1 molar solution or 1 atmosphere. So there's some discussion of that here in section 5, which leads to something which is called a concentration cell, which is the idea that you can actually take advantage of this fact of the derivations that we have in this section to figure out concentrations of ions in cells as long as they're electroreactive. So again, more examples shown in there. And then a brief discussion of what batteries and fuel cells are. Again, it's a fascinating topic. We could spend a whole semester just talking about batteries and fuel cells. We don't have that much time, unfortunately, but it's at least a nice little look at how that connects in with, what we see every day out there, right? We use batteries all the time. We don't want them to, at this stage, just to be something we don't know what they are, right? So now, once you've done this chapter, you can actually talk about them intelligently. And then the alternative to the galvanic cell is the electrolytic cell, which is instead of generating electrical energy from a chemical reaction, we actually put electrical energy in order to make a non-spontaneous reaction occur. And this is also very useful. So for example, metals like aluminum and titanium, which are so important in our modern society, they do not exist on the earth in raw form. You don't find just little deposits of aluminum or titanium like you might with, say, gold. So that means that we can use electrochemistry. That's essentially what we do, is we use electrochemistry to reduce these metals into their pure form. Then they can be used industrially, commercially. So that requires energy, and it actually requires quite a bit of energy. One of the reasons that people are asked to recycle aluminum and actually get paid for it, right? These deposits, is because it takes an enormous amount of energy to form metallic aluminum. It's a relatively recent idea that we would have metallic aluminum. It's really been in the last 100 years that it's been available for consumers and commercially. But it's essential for things like aircraft, right? For flying, you need to have aluminum. So we'll talk about that, electrolysis, some examples of that, how you get sodium and chlorine out of sodium chloride, and then you can also do it with metals. So again, there are calculations with this, and those calculations are shown examples of it. And then a brief discussion of corrosion. What is this idea of rusting and corrosion? And there's our chapter on electrochemistry. So I hope you enjoy it. It's a very applied type of chapter. It has practical applications that you can use. And it is also connected to some of the concepts that are important in biology, in particular physiology, cell membranes and such as that. So I hope you enjoy it, and good luck.